Good morning all. So today's session that we are going to conduct over here, the webinar that we have planned is for the composite analysis itself. So as you can see, the topic that has been mentioned over here. So this particular webinar is based on the advanced composite simulation or the analysis using the Ansys ACP module, and even not just the ACP module, but even how we are going to make use of the Ansys mechanical performing the composite analysis, like either preparing the model using the Ansys ACP, then how we can make use of the Ansys mechanical for applying the boundary conditions on it to particularly provide some structural conditions on it, structural boundary conditions or loading conditions on it, and then how we are going to do the post-processing part. So now we have the Ansys mechanical itself for the post-processing of the composite simulations as well. So we are going to look out onto those things. In the previous webinar, which was the part one of this sessions, so where we did saw how to particularly begin with the composite modeling, how to particularly make use of the like the surface model for generating a composite over there, then how to provide the variable thickness on the composite model or the particular surface that we did created. So over here as well, we are going to do the similar kind of thing, but just a little bit more advanced manner. So we are going to have a demonstration on a real world application as well, which is a Formula SAE car. So we are going to do a simulation on the monocoque of the Formula SAE car, and we are going to see how we are going to do the composite modeling on that particular model over there. So before starting with the session, let me just give an introduction about myself. So I'm Chetan Patil, working as an application engineer for Ansys FEA at ARK Info Solutions. So below my mail ID has also been mentioned over there. So if you guys face any kind of like issue with respect to the particular topic that we are going to cover over here, then you can just mention the queries in the chat box at the end of the session, or either you can mail your particular queries on the mail ID that I have mentioned over here. So we'll just begin with our session today. So first thing, like what all things that you should know whenever we are beginning with a composite simulation. So how Ansys does works in terms of working on the composite modeling or the composite analysis. So we have a composite pre-post module over here, which we call as the ACP. So basically, whenever you are beginning with the composite model or the composite modeling, then you should always know whatever model that you have. So whatever model that you might be going to use for the simulation, you should know what conditions you are going to provide on the model, what material you are going to use, what loads you are going to apply on the model. So the basic application about your particular model should be known to you. Based on that, you can make the selection what all conditions you are going to apply on the model. Based on that, you can make the selections on the overall geometry, and you can consider where to apply the composites, where to do the modifications on the model, and where to optimize your particular model using the composite materials. So over here, you can see how does the design of like the design cycle works for the composite simulation over here. So whatever model that you might have with you, so usually we do know how where we are going to apply the loads on the body, where we are going to apply the boundary conditions, and what materials we are going to use for the particular composite simulation. So once you know what all things you are going to do with your respective model, then with respect to that, you are just going to export. See, there are two different kind of methods those are available to do a composite modeling over here. So one is a shell modeling and another one is a solid modeling. So whenever you are beginning with the shell modeling, so shell modeling in the sense you will consider a mold surface over there. So as you can see the second image which is showcased over here, which is just a surface model. So basically, this is a shell model which is available over here. Sorry, the surface model which is available over here. And on this particular surface, now we are going to apply the composite laminates on it. And then we are going to create a composite model on it. And we are going to provide the thickness to this particular surface using the composite thickness itself, the laminate thickness or the ply thickness that we create. So once you know the particular geometry, you consider that particular body surface over here, and you should know whenever you are creating like whatever structure that you might be using for the simulation, you should always know how you are going to proceed with the composite modeling over there, whether applying composites on a particular surface where there are lot many number of curvatures those are available is possible, or whether we need to divide the particular model into smaller number of sections so that the composite layup might not get affected, the fiber orientation might not get affected. You need to be much precise with those kind of things as well. So over here, once you get the model surface that you want to do the analysis on, that you want to apply the ply on, so then you are going to take this particular model itself for the ACP model, where you are going to particularly apply the thickness, like where you are going to apply the particular thickness of the geometry itself. Either it might be a random thickness that you are defining over here at the initial, but later on, once you apply the composites on the geometry that you have selected, then you can even consider some more regions where you want to do the particular local refinements. So as you can see, if you have a particular model that you are going to use for the simulation, over here we just do particularly provide a mesh size over here to provide a random or an approximate kind of thickness, which is temporarily used at the initial. Then when you are going to use this particular model for the ACP module, you can define whatever material that that you might be using, the fiber that you might be using, you can define its thickness to the geometry, and whatever the thickness that you did define at the initial, that will get particularly changed with the composite thickness that you have applied. Later on, once you do the composite modeling on the particular surface model, then you are going to perform the structural simulation as well on it. And after the particular structural simulation, if you find out some more some regions where there might need some local refinement, or you want to increase the thickness over there, or you want to change the material that you are using in the local refinement region, then you can do those things as well. You can particularly modify the layup as well. So wherever you want to do the local refinement, that is as well possible over here. And the same kind of procedure is repeated once again, where you are going to modify the model with respect to the composite thickness, and then once again you are going to perform the structural simulation to figure out how the particular model will get affected with respect to the change in the composite modeling. So this particular process itself we are going to as well use for our particular simulation today. So when like why we are particularly using the Ansys ACP module. So what all things we can do using the Ansys composite pre-post, that is the Ansys ACP. So usually we can build up the composite design either using the shell or the solid geometries. So shell in the sense you can make use of the surface itself to create a shell of whatever composite laminates that you are using for the simulation. Then define plywise complex composite layups is possible over here. Defining fiber directions and orientation is available. You can modify and optimize composite design. So as we did figure out on the previous slide, so you can do the local refinement to particularly optimize your model. You can even reduce the material that is required, the weight of the material, the actual model weight can be reduced using the composite, and those simulations can also be run over here. You can analyze composite design properties as well and generate manufacturing information. Manufacturing information in the sense what kind of ply you might require when you are processing with like if you are using a particular model for the composite lamination or the composite ply creation. So what kind of ply you might require, so you can generate that manufacturing information as well. What kind of surface you might require if you are creating a ply, what kind of structure you might require if there is curvatures on the geometry. So if you want to acquire the actual curvature on the geometry, so how it can be achieved for the manufacturing process. So those informations can also be analyzed over here. So we are going to also see how we can generate the manufacturing information with respect to whatever plies that we might be using for the simulation. Then we will also evaluate the composite design. So evaluating design by means of composite failure criteria is possible. So whatever failure criteria you might define with respect to the material properties, those can be utilized for defining the failure criteria of your composite model. Then you can evaluate the reverse for matrix, fibers, and sandwich failures as well. Then there are many more evaluations that can be done with respect to the composite design. We will find out and figure out with respect to the demonstration that we are going to perform. So what like usually what process we do you follow over here? So basically we first of all create Ansys ACP pre. Then on that Ansys ACP pre, we usually once the setup is done for the overall composite model, then we usually import the static structural or whatever kind of simulation that you want to perform using the composite model. You can just import that analysis system over here and you can create your Ansys workbench project file. Basically the process that you can use for the simulation is mentioned over here. So previously we were using the Ansys ACP post, but that has been removed from here because the result or the post processing part that we were performing usually previously using the Ansys ACP post has now been integrated with the Ansys Mechanical itself. So we don't make use of the Ansys ACP post from previous version itself. So it has been removed from the Ansys Workbench platform over here, and we are just making use of the Ansys Mechanical itself for the simulation. So for the post processing and the simulation as well. So the pre-processing part is done using the Ansys ACP, where you are making the selection of the material, then you are importing the geometry, where there itself you are creating a temporary mesh on the model, which is particularly used to understand or give reference to the composite model, like how the fiber should be oriented or should be particularly applied on the model with respect to the mesh that you have created on the geometry. So for that purpose, the mesh is created over here as a temporary kind of meshing. Then you do the particular composite layup on the model that you have created. Once all this process is done, you take the particular composite model for the simulation where you apply the loads, boundary conditions and solve the simulation. And there itself, you can do the mechanical post processing, which is also mentioned in the Ansys mechanical post processing part. Now coming to the composite ecosystem, basically what all things you can do with the Ansys ACP pre. So what all things you can import or either what all things you can export from the Ansys ACP module, then what all things you can perform in terms of analysis. So that is also mentioned over here. So as you can see, it is particularly capable of importing the mesh from any third party application. So you can define the particular composite definition as well from the third party application. If you have some layup definition with you, you can import a CSV file where you can define the particular layup to the composite that you have created. Then you can export the models or the plies that you have created in terms of CADs, then flat wraps. So flat wraps are the particular manufacturing like model that you are exporting from the ACP post, ACP module itself. So which will help you with the manufacturing process, like what kind of laminate you need to create, the structure of the laminate with respect to the curvatures that you are trying to wrap up on the model. So all those things we can export over here. So we'll discuss about those things in the demonstration as well. So you can even define the composite definition using the third party application over here. You can export to make use of whatever composite definition that you have done to any third party application as well. So all these things are capable and all things are particularly eligible to be done using the Ansys ACP pre-module. Then this particular system itself can be or the module itself can be exported either in terms of shell or a solid geometry. So whatever modeling that you have done either in terms of surface modeling or either in terms of solid modeling, so that can be exported and that can be particularly used for performing different kind of simulations. Either it might be a structural thermal, then a 3D printing process or a curing process. Then you can make use of the same composite model for the fluid simulations as well. So all these different kind of simulations can be performed, and even Python scripting is allowed to particularly launch the ACP module from Python itself and do the particular modeling of the composite through the Python scripting itself. So all these things are possible using the Ansys ACP composite pre-post itself. Then what all key steps we need to consider whenever we are processing with the ACP module? So as I did mention previously itself, we do define the materials, then we do particularly import the geometry, then we do define the layups on the geometry using the Ansys composite pre module over here. the orientations of the fiber, then the particular directions of the fiber. All those things are done using the layup option that is done in the setup over there. Once that is done, you do the particular model review over here. After reviewing it, you can take your model for the post processing part as well. So those particular key steps you need to keep in mind whenever you are performing a simulation. So like what all things you need to consider, or what approach you need to particularly consider whenever you are beginning with the like ACP module or creating a composite. So uh, usually the philosophy over here is defined as model as you build approach. So basically whatever approach that you usually use to building a particular model or developing a particular composite model, the same kind of approach you need to make use of over here as well. So whatever mold surface that you might have where you want to apply the composite on, so that particular surface you need to create at the initial. After that is created, then you need to apply the plies on the model. So that is usually the processing part itself. So we'll see how this particular process is performed over here. Then after applying the plies on the mold over here, with respect to considering the manufacturing like capabilities as well, and even whether it is possible to do the like do the building process or the manufacturing process, whether it is possible or not with respect to whatever conditions we are applying on the model, we need to consider those things as well. So over here, once you apply the plies on the mold, then you can particularly process it for the post processing part, simulation part and the post processing part. And you can make use of the local refinements as well and local reinforcements as well, to particularly provide some amount of strength to the model. And that particular process can be considered to be the actual manufacturing process as well. So as you can see, the plies are directly applied to the model in a process which mimics the actual manufacturing process. So the same thing that we are going to do over here, we are going to see those things as well. So composite workflow, as we did already discussed, we are going to perform a ACP pre-module over here at the initial to create the composite on whatever geometry that we might have. And then later on, whatever composite that we have created, we are going to make use of it for the structural simulation. So whatever structural simulation we want to perform, so we can make use of that particular analysis system over here on the ACP setup. So usually defining the material is the most important thing. So we are not going to go much into the detailing about how the ACP is done, or either we are not going like how the ACP module is run over here in the like theory kind of part itself in the slide. I won't be mentioning about them. So how we are going to proceed with the ACP module, we did already saw in the previous webinar as well. So in this webinar as well, we will go with the demonstration where I'll showcase you how all these things are done. So how we are going to define the material over here, or either whatever materials those are already been present. So how we are going to make use of them for the simulation, we'll see those things as well. Then as you can see, the ply must be defined. So Ansys composite pre-post applies the particular right failure criteria. So over here, whatever ply type that you will choose for the simulation, that can be considered from whatever the types those are available in the ply type. So based on whatever material you are selecting and whatever the kind of properties that you are selecting at the initial. Then some failure criteria need additional constants as well. So those things can also be saw when we'll proceed with the like failure criteria post processing part. So at the post processing, we'll find out what all things we can post process, and based on that, we can apply those constant in the material definitions as well. So as you can see, for the post processing, what all kind of failure criteria are available. Maximum strain, maximum stress can be a criteria. Saiwu, Sahil, Hoffman. So all these kind of failure criteria are available. So you can define these kind of failure criteria to your particular material that you are using for the simulation. So based on that, you can find out where the particular failure is getting generated and how to particularly optimize that failure on the model. So this demo that we are going to perform over here. So we are not going to go much into the theory part. So over here, we'll directly jump on to the demo itself. So we are going to make use of a monocoque model, that is a formula SAE monocoque. So on that particular monocoque model, we are going to apply composite layups and definitions so that we can increase the strength of the model with respect to the structural conditions that we are going to provide over here. And we are also going to see how we can do a parametric study for a composite model that we are going to create over here. So first thing that we are going to see in this demo over here is basically we have a FSAE monocoque model, that is a formula SAE monocoque model. So we'll go through the complete process of modeling, solving and post processing over here. Then step by step we'll proceed with the modeling and the post processing. So what all things that we are going to do in the pre-processing part, so that we are going to discuss in more detail till the modeling part. And then we are going to apply the simulation conditions, that is the structural conditions on the model, and we'll go for the post processing part. And also we'll see how we can apply either a variable core thickness, or either if we are keeping some different kind of thicknesses to all the particular structures that we are going to use for the ACP. So how we are going to provide different kind of thicknesses and all. So we'll look out into those things as well. So what kind of model that we have is like the actual model might look a little bit different. So we are going to extract this particular model part itself for the simulation. So this is the formula SAE chassis that we have with us. So we are going to take this model for the pre-processing in the Ansys ACP. So we'll also plot a thickness after ply layup over here. So whatever the kind of model that we are going to use for the simulation will not have any particular thickness over here, because we did already discussed either you can make use of a solid model or either you can make use of a shell model. So we are going to make use of a shell model over here. So whatever the thickness that we are going to provide to the geometry, so that particular thickness will be equal to this particular thickness that is already provided to it, but it will be totally created with respect to the ply layup definitions. So we'll discuss about those things, and then we'll plot the particular thickness plot, so we can figure out how the definition of the, like how the particular ply layup has been created, and whether the thickness that we have already been generated for a solid model is applied over here through the composite or not. Then firstly, we are going to go and work on with the geometry preparation. So that is the most important thing. So whatever solid geometry we do have, we are going to convert it into a shell model. So that particular geometry itself, we are going to make use of for the simulation, and we are going to apply the conditions on the model with respect to the suspensions due to the front wheel. So that particular things also we are going to create on the geometry over here. So with respect to the composite manufacturing process, thinking about the manufacturing process and feasibility for the manufacturing process, we need to modify some part of the geometry as well. So we'll discuss about those things in detail. So after that, in the pre-processing part using the Ansys ACP, we are going to create the fibers with respect to the materials that we did selected over there. And we are going to create the rosettes for defining the fiber orientation and the directions of the fibers that we have created. Then we are going to apply the ply orientations over here. So in which particular direction we need to provide the thickness. So it does totally depends on what surface that you have selected at the initial from the solid geometry. So if we would have selected the external part, then we need to provide the ply orientation in the inner direction so that the thickness won't be generated in the outward direction. So that would be a irregularity with respect to the geometry. Then if we are particularly defining the ply orientation and all, how we are going to work out with those things with respect to the directions or the rosettes that we have created. Then how we are going to model the ply. So we are going to discuss about those things as well. Then further we are going to check how to particularly create the section cuts to visualize whether whatever the plies that we have created are properly oriented and aligned or either layup or not. So we'll find out and figure out those things as well. And then we'll take our model for the structural simulation where we are going to apply the torsional boundary conditions on the model. So wherever the like suspensions of the tires are attached to the monocoque directly, the chassis directly. So there we are going to apply some torsional conditions on both the sides of the monocoque, and then we are going to analyze the particular behavior of the model. So this the last step that we are going to do over here is the post processing of the ANSYS, post processing of the model. Then where we are going to do it is the ANSYS mechanical itself. So we don't have ANSYS ACP post for the simulation over here. So we'll directly begin with the simulation over here. So I'll just share my screen for ANSYS workbench as well. Just a second. Okay. So as we are on the workbench screen over here now, so basically we'll proceed with the Ansys ACP itself. So first of all, I'll just drag my ACP pre over here and drop it into the project schematic window. So what all materials that I want to use for the simulation, I'll keep it very much simple because this might be a lengthy process. So I don't want to waste much amount of time with the like material selection and the properties that we're going to use for the simulation. So I'll just make use of some random composite materials which are already present in the ANSYS library over here. So I'll just right click on the structural steel because this is not the material that we are going to use for the simulation. I'll click on the engineering data sources over here. I'll go to the composite materials library. So first of all, I'll click on the composite material library. So we have lot many number of materials which are present over here. So usually whenever we are creating kind of composite ply or a particular layup or a laminate. So usually it does depends on what kind of materials that you are using. Either it is a unidirectional material or either it is a particular woven material. So it does depends on those things as well, and the strength does also varies with respect to them. So we'll first of all go with the epoxy carbon woven material itself. So we have this material defined with respect to the orthotropic elasticity property, and the ply type has been defined to be the woven itself. So I'll just click on the plus symbol to add this material for our engineering data. Then after that, I'll also make use of a honeycomb structure to provide some more amount of strength with less amount of particular weight of the material. And even it might provide more amount of thickness with less amount of material usage over here. So after that, I'll also make use of resin epoxy. So if it is required, we can make use of it. But usually it is not required. But still, if required, somewhat in between the particular modeling process, so we'll make use of it for the simulation as well. So I have added three number of materials over here where I have the epoxy carbon woven material. Then I have the honeycomb structure where the ply type has been defined to be honeycomb structure itself. Then the stress limits have been defined over here. So as you can see, the stress limits have been defined. So which particularly implement with respect to your failure criteria as well. So you can see your failure criteria of the material with respect to the stress limits and strain limits. Those have been set to your material that you have selected. Then if we would go to the geometry, so I have the geometry already with me. So I'll be making use of this geometry file. I'll just showcase you what kind of geometry that is available with me. So I have made some kind of modifications already on the model. I'll just showcase you how those modifications have been done. And if required, I'll just go through the process once again, like how that modification has been done over here. So let it open in ANSYS space claim. Okay. So as you can see, the kind of model that we have over here, the actual model which was already been present with us. So I'll just delete the surface that has been created over here. Even the origins that I have created, I'll just delete those all things over here. I'll just right click and show all separate geometry. So as you can see, the kind of model that I was having from the initial. So I'll just activate for physics to the overall geometry that I have with me. So as you can see over here, I have this overall model, and from which I'm just trying to analyze this monocoque model which is present over here. That is the chassis model that I have. So I want to increase the strength with respect to the composite materials for this model over here. So what I can do is I can just right click on this particular model over here and hide this model which is present. Then later on, whatever the overall geometry that is present, I'll just right click on it and click on select to select overall geometry which is present over here except the chassis model. I'll right click on it and suppress for physics. So after that is done, I'll just hide or either I'll just click on show all geometries at the initial and then click on hide suppress geometries over here to just showcase my monocoque chassis model which I'm going to use for the simulation. So once this is imported over, this is selected over here. Now, as you can see, this is the structural or a solid model which is present with us. So we don't want the solid geometry to be able to be used for the simulation. So as I want this model to be used as a surface geometry to make the philosophy being applied over here for the composite manufacturing. So I'll select the overall surfaces of the geometry by double clicking on the model top surface. So I'm not selecting the inner surface. I'm selecting the outer surface over here. So I need to understand about the orientation of the plies as well. So over here, I have selected the top surface of the model. I'm selecting the front end of the model and even the rear end as well. So these particular faces I have selected from the model. I'll just press Ctrl C and once again I'll press Ctrl V over here. So my surfaces have been imported on the geometry which is present over here. I'll just right click on the chassis and suppress it for physics and hide this particular geometry. Now I have the surface model with me that I can use for composite lamination or layup. So basically this model that I'm going to use for the layup. But before that, I need to make some modifications because there might be some issue with the model as well. If you would see, there might be some issues in the model in very smaller kind of regions of the model. So that won't be like actually visible to you because I figured out those things when I did clicked on in the repair tab. I was just checking with respect to the particular properties which are present over here, the tools which are present. I was just randomly clicking over here to figure out whether there is some issue with the model or not. So first of all, I'll just go with the designing over here. Now, whatever the model that I have, see, applying the composite directly as a laminate is not possible over here because there is a particular closed loop which is present over here. And applying a composite in a closed loop is not possible. So what we can do is we can divide this overall geometry into half sections so that it will be easily be like possible for us to create the laminates in terms of the manufacturing or the molding process as well. So what we'll do is we'll divide this model into half of the part so that whatever the composite that we are going to use for the top section will be different and the bottom section will be different. Both of them might have the same kind of layup itself, but just we are making some kind of bifurcation with respect to the model, division with respect to the model, so that it will be feasible with respect to the manufacturing process as well. So how this particular division we are going to do is we are going to make use of the split over here because 50-50% of division should be done on the overall geometry. So we can't directly create a plane in the half of the section and divide this particular model into half or two equal parts. So we'll just make use of the split tool over here, which is a face split or edge split tool. I'll select a face over here. Then I can just select whatever edge I want to, or whatever the particular edge with respect to which I want to divide the face that I have selected into half of it. So I'll just mention 50% over here. So it will automatically divide my surface over here into half. Now, after this, I want to do the same kind of modification with the overall sideways of the geometry. So I'll select this particular surface over here. Now I can't divide this into half by just clicking on the particular tool which is present over here, that is the UV cutter point. So basically this tool is only used whenever there is a symmetric surface or both the sides of the face are particularly of similar sizes. At that time it will work to divide the model into half of it. Rather than that, we can make use of two cutter points over here, where I'll select the first cutter to be the half of this particular surface and second to be defined over here with respect to the value that is 50% over here. In the similar way, we are going to divide these remaining surfaces as well. So this might take a little bit of time. So you should be more precise with defining these particular divisions as well. So it will be more feasible while taking this model for the manufacturing process directly over here. So whatever the kind of like divisions that we are making over here, this will particularly help us with the composite layup as well. And particularly after laying it up on the model, we can even find out what kind of manufacturing layup we might need. So the layup that we are directly applying over here is with respect to the geometry. But whatever the manufacturing ply that we need to create, that particular ply, what should be the actual dimensions or the actual geometry of the ply that we are going to create. So those things can be exported through the flat wrap option. So we are going to discuss about those things as well. Firstly, let me just divide this particular model into halves using the cutter tool. Okay. So as you can see now, my model has been divided into like two number of equal parts over here. Once that division has been completed over here, I'll just press escape and go to the repair tab over here. Now, if I would click on the stitch tool, so it will try to recognize whether there is some kind of issue on the model. So as you can see over here, there might be some kind of overlap on the model or there might be some amount of gap over here. So it has detected automatically these regions over here from the overall geometry itself. So you can see there are some more number of region in the similar way. So I'll just completely fix all of them together over here by clicking on the green tick mark. Once that is done, we can find out whether there are any kind of gaps or missing faces on the model. These missing faces are just the opening regions, so those are required for us. So after that, we can even figure out whether there is some split edge in the model. So I don't think so. This might be an issue. Okay. So there are no particular like regions which are needed to be modified from the model. Now, if I would go to the prepare tab, because I want to create some imprints on the model, on this monocoque model, basically to apply the torsional boundary conditions, because those are being applied due to the suspensions of the tires with respect to the chassis that is available over here. So if I would click on the suspension over here, you can see those suspensions are not directly connected to your monocoque model, but these suspensions which are available over here, these particular smaller sections which are available, those are the particular regions where we are going to apply the boundary conditions on. So if I would just activate those or either just unhide those and click on the imprint option, it will automatically generate the imprints on the monocoque model that I can use particularly for providing the boundary conditions on them. So it has automatically generated the imprints on it. So I'll just create those and escape and remove the suspensions that I created. After this, I'll just like fill these regions because these are not the regions where we are going to apply the conditions on. So I'll just select these particular regions from the model where I'm not going to apply any particular conditions over here. So I'll just fill those. Once that is done, Now my model is actually ready for particular uh, composite modeling over here. So once this is done, I'll just minimize the screen and go to the modeling model over here, where I can particularly generate an initial meshing over here on the model. So that particular mesh will be used for the simulation of or either providing just the orientation on the model through with respect to the element sets those will be created on it. So that will help us to particularly discretize the model as well with respect to the elements on the selected surfaces. So how it is done? So I'll just right click on the model and open the Ansys Mechanical to generate the mesh on it. Okay, so the model has opened over here in the Ansys Mechanical now. So whatever like the model that has been imported is a surface model over here. So we need to provide some amount of thickness to this model so that like this is just a temporary thickness, cause whatever the thickness that is actually being going to be applied on the geometry will be with respect to the composite that we are going to create. So based on the layup thickness, so that will be directly applied to the model. So we don't have to worry about whatever thickness that we are going to provide over here. So we'll just provide a random thickness of 1 mm to the overall geometry itself, and we'll just make a random material selection, because whatever settings that we are doing over here with respect to the geometries, that will not be considered further for the composite modeling. So this is just the initial process to create the mesh on the geometry, so you can make use of whatever changes that you want to make with respect to the geometry. So after that, okay, so just one thing was left out over here, that was particularly creating the coordinate systems where we are going to apply the torsion. So that would be with respect to the wheel suspension. So that means we need to create some coordinates over here. So I'll first of all create a origin on this particular surface of the model, and another origin on this particular surface of the model. So these two regions I'm creating. Okay, so just a second. Okay, so I have created these two origins over here. I'll go to the mechanical and I'll just update the geometry from the source so that the coordinate systems will be getting imported over here once again. Okay, so both the Cartesian coordinates have been imported over here properly. Once this is done, I'll just go to the mesh to create a random kind of mesh, but it should be a uniform kind of mesh itself, because this will particularly affect your composites that you are like whatever composite that you will be creating. So the fiber orientation and all other things will be getting affected with respect to the mesh. So even if you don't create more finer mesh, that is okay, but you should create it in a better way itself. So I'll just define a random value of 10 mm over here and generate the mesh on the model. So we'll just check what kind of like mesh it will create on the model. So as you can see, it has already created a fine kind of mesh itself. So if it would be much focusing on the particular curvatures of the model, if I would turn on the curvature over here and generate the mesh once again, so it would create more finer mesh on the geometry, as we usually do know. So as you can see over here, some of the regions on the geometry are getting affected due to the curvature that is present over here. So we don't want to make use of that particularly, because we need to keep the mesh in more formal way itself. So we'll make use of the default setting itself. So we are not going to modify anything over here from the geometry. So you can see the thickness that has been provided to the geometry with respect to 1 mm of thickness. So as you can see, there is just a small amount of thickness that has been applied. So that is just a random thickness that is not going to be applied to the actual composite model. So once we are done with the meshing, we'll just go to model over here. Now I need to create the like element sets means basically the name selection. So wherever you want to apply different kind of composites and all, so you can choose those particular regions from the geometry where you want to apply different kind of materials, and you can particularly make use of it for the layups over there or the definitions of the composites. So over here, first of all, this is the frontal part of the geometry. So I'll just select both the things from the front part. I'll mention N over here and mention the name selection as front. In the similar way, I'll select these parts from the back side. I'll select these regions from the model and I'll define these as the rear of the model. So once these two things have been defined, I'll select in the similar way the sitting area, that is this particular region. So whatever regions those have already been selected, you don't have to select them once again, because that will just create an irregularity and might create some kind of errors. So this I'll define at the as seat over here. Once that is done, so I'll just select the top surface of the model where I want to apply the composite on. So I'll just select these particular regions over here to be the top surface on the model. Okay, so once all these surfaces have been selected, I'll just name it as top mold in the sense. So basically whatever the mold that we will be creating, so that will be with respect to these selections that we are making over here. And whatever the bottom will be there, so I'll just select the bottom mold regions over here. So this might look like a lengthy process, but this is actually necessarily required to create the composites on the model, uh, to particularly keep everything in our hand. So not this region over here. Okay. So once all these regions have been selected from the geometry over here, cause the fiber orientation and the fiber direction might get changed if we are choosing overall or different kind of geometry sections in the similar regions over here. And whatever I have selected, the bottom part over here, but in which I have also included these regions. So I want to showcase you how the particular wrapping or draping process will be applied over here on the model, and how it will be used or exported from the Ansys ACP module to create a manufacturing layup over there. So what I'll do is I'll just create a name selection for this one as well and it as bottom. Once this is done, I'll make selection for the left and right hand side as well. So I'll just select this particular region over here and mention it to be the left top panel, and this particular region to be the left bottom panel. After this, we'll go for this another side of the model. So this top end, I'll name it as right top panel, and the bottom will be named as right bottom panel over here. Just check once whether it's something left out from the overall geometry or not. So if nothing is left out, so we'll also create a wrap up over here. So I'll just select all the number of faces from the overall geometry where we can create a wrap up on the overall model. So that will be just a particular process where we are going to make use of some kind of composite to provide just some amount of strength and to keep all the number of like corners and all to be covered with respect to a single wrap itself. So we'll select all these number of surfaces which are present over here. So this might be a little bit lengthy kind of process itself. So making selections and all. Okay, no, this one. Okay, so these many number of faces I have selected over here. I'll just name it as wrapping. So that will be a particular composite layup that we will be creating over here, or a ply that we will be creating, which will be applied at the end of the particular layups, so that all the number of regions which we have created as different kind of composite, those will be covered with respect to that layup at the uh, end of the composite modeling. So once all these name selections have been done, so if you would check all of them to be selected together, whether there is some kind of faces those are left out or not, you can just recognize those things. So nothing is left out over here, so we can just move ahead with it. So I'll just minimize this thing. I'll go to the workbench. I'll update the model which I have created over there in Ansys Mechanical. Once it is updated, I'll go to the Ansys ACP setup over here, so that now we can begin with the composite modeling. So the actual process for the composite modeling does begins from here. All these things we did already covered, like how the thickness is supposed to be provided, why we are providing the thickness and all other things, the name selections that we did created over here. So why we are creating those name selections over here. So all these things we did discussed in the previous webinar as well. So over here, now whatever the name selections that I did made, so those name selections can be used as the element sets where I can define different kind of composites or different kind of layups on the composite model. So now you can see my composite ACP has been opened over here. I have the model which is open. Firstly, I need to check the unit system that is being used over here. So the maximum thickness provided is of 1 mm, which we did define in the ANSYS mechanical model. So it is in terms of meter over here. So I'll first of all change the unit system from MKs to MPa. So which will convert my model to mm. So over here now, whatever values I will be defining, so that will be in terms of mm itself. So if you would change the unit system for both the models, then the composite layer will also get disturbed with it. So first of all, we have the materials with us, the epoxy carbon woven, the honeycomb and the resin. So first of all, the first step that we need to do over here is to create a fabric. So firstly, we'll create a fabric for the woven material over here, which might have a thickness of 0.4 mm. And I'll just go for naming it as a woven material over here. Just a second. Woven material. Now, once this is done, I'll just click on apply. So this particular thing will be applied on the model, or it will be created at the initial. It will be not applied directly when we'll select the particular orientations and all. At that time, we will apply these things over there. So firstly, we'll check what kind of like stiffness it might have in all the directions with respect to the polar coordinate. So it has more amount of thickness in the 90 degrees or the 0 degree angles over here. So basically, if we might create a stack up with the similar material oriented at an angle of 45 degree, so it will have a similar kind of stiffness in all the number of directions over here. So what we can do over here is we'll just have a look on those things as well. So first of all, we have created a fabric for the epoxy carbon woven material. Similarly, we'll create a material for the sorry, a fabric for the honeycomb structure as well. So I'll mention it as core over here. The thickness for this honeycomb structure would be 10 mm, and I'll just click on apply. So it has a similar kind of stiffness in all the directions, so we don't have to worry about it. So once that is done, we'll go to the stack up. So stack up in the sense, basically we are going to make use of any fibers to be used in a particular oriented manner or in a composition manner. So that will help us in creating directly over here instead of using them differently for the ply modeling. So over here we have a stack up that we have created. So now what kind of stack up that we are going to create is, we are going to make use of the woven material uh, over here with respect to different directions or different angles oriented with respect to each other. So we have both the woven materials, those are selected over here. The angle of the first woven material is 0 degree, and we did saw what kind of polar coordinate it was showing us with respect to this angle. So if we would change the direction for the another one, so I'll just mention this one as structural stack up that we are going to use for the simulation. So I'll just name it as sorry. Okay, so I have just named them as the structural stack up over here. I have defined the first woven angle to be 0 degrees itself and the second to be oriented at 45 degrees. I'll click on apply. Once it is applied, you can see a structural stack up has been created. And in the analysis, I'll just go to the polar coordinate to analyze the E1 over here. Now you can see we have a polar coordinate where you can see the E1 value has been distributed equally in all the directions. So this has particularly increased its strength in all the directions. Now we have a similar kind of material property to be defined in all the directions for the material. So we have this stack up to be created over here, which we are going to use for defining the composite layup for the overall model itself. Now, after defining the stack ups, you can see we have different number of element steps over here. All elements in the sense the mesh that we have created for the overall geometry will be present in the all elements. We have the front section. So based on the name selection that you have created, the elements on the geometry has been discretized over here. You can see the front in the sense the elements those are present at the front section will be just showcased to you over here. So first of all, see the selection that has been made and the number of elements which are present on the front section will be just used for the particular composite layup. Then the wrapping, in the similar way, the rear model, rear name selection, the seat, the top, bottom, left, right, all these number of elements set that we did created using the name selection are present over here. Okay. So once this is done, okay. So once this is done, we'll first of all not make any kind of changes in the element sets because those have already been created by us manually. Then we will go to the rosettes over here. So rosettes are basically used for the fiber orientation and the directions over here. So we need to create the fiber orientation and direction with respect to the name selections or the particular regions that we did created the element sets for. So I'll just right click on the rosette, create a rosette. So first rosette that I want to create is for the top section. So it does totally depends on you which rosettes you will be creating. So this is just the particular section where you are defining what should be the fiber orientation, if it is the top section or the bottom section or the front section or the back section or the sideways section. So whatever section that you will be creating the rosette for, it will have its own fiber direction. So none of the particular different region will have different kind of fiber directions over here. So that will increase the strength of the fiber orientations as well. So over here, first of all, I have named this as the top section. Firstly, I need to define the region over here. So I'll just select the top section of the geometry. So over here, this is the particular simulation that we are performing on XY plane. So all the surfaces will be considered to be present on the XY plane itself, and Z will represent your particular layup direction. Layup direction in the sense the thickness direction. So we'll firstly we need to find out which is the thickness direction. So thickness direction currently is in the Y direction over here. So the second direction is your Y direction. So we'll just change this particular Y to Z over here in the second one. After changing it, you can see the Z has been created in the inner side. So inner side is the actual correct orientation of your particular rosette over here, because the thickness is also in the downward direction itself. So that has been created. Once it is created, I'll just click on apply and OK. Similarly, we need to create multiple number of rosettes in all the 6 directions over here. So I'll just create all of them quickly over here. So I'll firstly define the bottom region origin for the bottom. I'll select this one. So over here you can see Y is again in the top direction. So I need to change the orientation over here from Y to Z. Now the Z is in the downward direction, but we want it to be in the upward direction. So we'll flip the direction of the rosette that we did created and click on apply. So always your Z direction should be in the thickness direction over here. So as you can see now, we have the particular thickness to be provided. So that's getting a little less. So it's okay. But now the Z direction is in the thickness direction itself. So we'll create similar rosette for the front and the back as well. So firstly, I'll define the front, where I'll select the origin. So the front origin will be somewhere over here. So it doesn't matter which region you are selecting for defining the origin. It is just to particularly select a point from the model through which you are defining in which particular direction the thickness should be there and the fiber orientation should be there. So fiber orientations are usually done in the XY direction itself, because the polar coordinates are also tending in the XY direction. So now over here, we have the particular Z direction to be in the outward side. So we'll just change the particular Z direction over here. So what we are going to do is, okay, so we already do have the Z direction over here. Okay. Yeah. So we did flip the direction of the Z in the inward direction over here. I'll click on apply and okay. Now similarly for the rear section as well, I'll create a rosette over here and name this rosette as uh, rear, and select the origin from the model over here. Now the origin has been selected and we have got the actual direction of the z-axis in the inward side itself. So we don't have to make any changes with the directions. So I'll just right click on the rosette to create the rosette once again for the sideways as well. So this is the left side. So I'll just name it as left over here and select the origin for the model. So I'll select this particular origin over here. Now once the origin is selected, I want the particular z to be present in the negative x. So I'll just select this as 0 and this as 1 over here. After it is selected to be 1, you can see the fiber orientation and the direction has been changed. Not the orientation, sorry, just the direction has been changed. Similarly, for the right side, I need to define the origins over here. So I'll be creating the origins for this side as well. So I have selected this to be the origin. So X itself I need to change once again. So I'll mention it as 0. This to be 1 over here. Now just the Z direction is in the outward direction. So I'll just flip it in the inward direction, apply and OK. Now I have created all the rosettes in all the directions of the model, that is the top, bottom, front, rear and the left and right of the model. Once these rosettes have been created, now I need to apply the particular composites in the oriented directions. So how I'm going to do those things over here? So first of all, whatever the particular name selections that I have done, that is the front, the rear and all other things. So I'm just selecting the particular sections over here and defining in which particular directions the fibers for those are getting generated over here. So if I would just right click on the orientation and create an oriented selection set, firstly I'll need to select this element set over here. So I'll be selecting the top section. So if I'm selecting the top section, I'll name this to be the top itself over here. Now the top has been selected. I need to particularly define the point. So just select a particular point on your model over here. So you can see your model point has been selected, and you can see the direction of your particular fiber orientation or the thickness is considered to be in the outward direction. So I want it to be flipped inside. So your thickness will be in the inner direction. Now, after that selection, you need to select the rosette as well, which particularly defines the fiber directions or the fiber orientations. So over here, firstly, we have the top section. So top section is particularly having lot many regions over here. See, the top does also have the sideways of the model as well. So you need to select rosettes which have uh, directions in all the three ways, that is in the top section as well and all also in the sideways. So I'll just select the top over here. See me with respect to it, I'll select the left and the right as well. So where I have particular surface created in all the three directions, so I'll be selecting all the three rosettes that I have created in the three directions and apply and close it. So now I have applied the first section for my oriented selection set. So I'll be creating a second oriented selection set. So that will be for the bottom. So bottom is present over here. So I'll be selecting a particular point. So this would be my point for the orientation. I'll just flip it inside. So always it will show in the outward direction itself. So you need to flip the direction in the inner side so that the thickness will be generated in the inner side of the model. Now the rosette does also have the bottom side and the sideways. So I'll select the rosette, the bottom and the left and right. Apply and OK. After this, OK, so I didn't change the name for it. So I'll name it as bottom over here. Apply and OK. So I'll create a new orientation selection set. So the element that I will be selecting over here will be for the rear side. So rear is present at the back over here. So I'll just select any point, flip the direction over here. A rosette will be created just for the rear over here. Apply and close. Now for the front, I'll do the same kind of thing over here. So rear. So it will be better if you would name everything with respect to the selections itself, because it will be easier for you to understand which plies are oriented with respect to which element surfaces. So I'll create a new oriented selection set. So this to be the front of the model. The element set over here will be your particular front section. The front, I need to define just a point over here. So point, I'll just select a point on the front surface and flip the direction for providing the thickness in the inner side and select the front for the rosette over here. After that, I'll just apply and click on OK. Now I need to create more number of oriented selection sets over here. So this is a little bit lengthy kind of process that you might find out. So now after that, I have the seat over here. So seat needs to be applied with respect to the orientations itself, the rosettes itself. So I'll just select a point on it, flip the direction, a rosette to be created from the top itself. So only top is, I guess, though will work out for the particular seat section over here. I'll name it as seat, apply and OK. Create another oriented selection set. Now this oriented selection set I'll be creating for left panel, bottom panel, right and right bottom panel. So all of them have the similar kind of like regions over here. So I'll be selecting all of them together. I'll select a particular point over here and select this region. So I want the orientation to be applied in the inner side. So either making the selection in such a way would work out, or else I'll just make the selection for different kind of regions in different way. So I'll just select the left up top and the left bottom together. So the point that I have selected over here is in the proper direction. So the reset that I need to select over here is the left one. I'll click on apply and close. So, okay. left panel. Now for the right panel, I need to do the same kind of thing over here. So I'll define it as right panel over here. Select the element sets, that is right top and right bottom. The point that I need to select on the model, I am selecting over here, flip the direction. The rosette for it will be the right one, and apply and OK. Once this is done, the just left out one is the wrapping over here. So I'll select the wrapping over here as well for the element selection set. So over here, the point I'll select is the rear one itself. So you can select any particular point from the model. So I'm just selecting the rear one for this wrap because this is created for the overall region itself. So you don't have to worry much about the uh, particular orientation about it. So the rosette that I'll be using over here will be the bottom, not the front, the top, the rear, left and right. So all these will be applied together for this wrapping section. So once this is selected over here, I'll click on apply and then OK. So I have created all the number of oriented selection sets for the model over here. After creating the oriented selection set, we are going to use this oriented selection set for creating the modeling plies over here now. So I'll just right click on the modeling group. So after clicking on the modeling group, I'll name for the top section to be the top over here. I'll right click on it. So click OK. I'll right click on it, create a ply. So this ply will be oriented with respect to the top section of the model, where I'll be using a structural stackup, which will be of two number of layers. See, the previous stackup that I did created was just of one layer. So now the similar stackup I'm using over here to be available for two number of times. Then after making use of it, so I'll just click on apply over here. Once two number of layers of structural stackup is being used, you can see there is a particular variation in the overall curvature model. The fiber orientation at the top might be in the plane itself, but later on there is curvature in the particular top and bottom sections. So what you can do is you can make use of the draping over here. So internal draping can be provided where you can select a particular seed point from where the particular fiber orientation should be started, and it will create a draping for your model which can be used particularly for manufacturing process. So if I would click on apply over here and click on OK. So once that is done, I'll just go for the another ply that I want to create after this first ply. That will be for your particular core section. The same orientation will be done for the top itself. Sorry, top itself. And then the number of layers for this core is, will be one number of layer itself. Apply and OK. Now after this, there will be another ply which will be present over here for the top section itself. The ply type will be the stack up angle itself. Okay. After this, the number of layers will be remaining the same. The number of layers we will be going to use for the top section will be 2. So basically the ply that we have created with respect to the composition is, first we have a structural stack up layer of two number of layers over there. So the stack up already has two number of fabrics over there. The woven fabric, which is already been oriented with two different directions. So that has two number of layers used at the initial, that is on the surface of this model. Then on that particular stack up, we did applied a particular core, that is the honeycomb structure, which is of 10 mm thickness. And then after that, we are making use of the second structural stack up layer, which is also of two number of layers over here. So that will be also used with the draping itself. So we'll provide a seed point over here once again, apply and click on OK. So this was done for the particular top section. So in the similar way, we are going to create modeling groups for all the remaining sections as well. So this is a little bit lengthy kind of process itself. So I know it might take more amount of time. So I'll create it quickly. So I'll select the bottom side as well, where I'll be using the structural stackup, which will be two number of layers. Then I'll go to the trapping to provide internal trapping. And over here, the seed point will be this particular point. Okay. So it has created the particular draping as well for the model. After this, I'll create another ply which will be of core, and the particular oriented selection set will be your bottom oriented selection set. Sorry, bottom oriented selection set. Apply and OK. After this, again there will be a stack up layer that will be used. So bottom, a stack up layer which will have two number of layers over there, and we'll be making use of an internal trapping over here. So internal trapping is only used whenever you are trying to acquire the actual curvature, so that whatever the fiber orientation or the fiber direction that will be changing with respect to the change in the curvature, that can be properly achieved with it. And with respect to the manufacturing process as well, how we can make use of this section, we can find out with respect to that. So after this, because creating a composite of similar kind of manner is not actually possible. So manufacturing perspective is also supposed to be considered over here. So that's why draping does helps you with creating a particular geometry which will be suitable to achieve such kind of uh, particular region in the manufacturing process. So I'll just showcase you that thing as well. So over here, I'll create a new modeling ply for the front, apply. Okay, create a new ply over here which will have the oriented selection set from the front. The ply material will be the stack up, which will have total 6 number of layers over there. Once 6 number of layers have been selected, I'll apply it and click on OK. See, I didn't apply any draping over here because it is just on a single plane over here, so I don't have to worry about the draping over there. So wherever there is curvature in the model, we usually use the draping over there itself. So front, the core that I want to use at the middle over here, apply. Okay. After this, there will be another apply that we will be going to use. So that will be also with respect to the front orientation, stack up, and there will be 6 number of layers over there. After this, after the front, we'll go for the back over there. That is the rear side. Apply. Okay. Right click to create apply. Select the oriented selection set for the rear side over here. First, structural stack up for 6 number of layers. Apply. Okay. Then again apply after that, which will have the same oriented selection set, but the material that we will be using over here will be the core. Apply. Okay. So this might be little bit time consuming itself, but it is required to be done. So that's why usually whatever the kind of layups is there, so whatever the modeling ply layup is there, that is usually exported from model that you have already created and exported in terms of CSV file. That CSV file can be directly imported over here to define the layups over here. So that might save your particular time, but it is also a manual process that has been created using some different software. So you need to create it either manually over here or either in some another software. So we'll create left panel for left panel. Okay. So over here, create apply oriented selection set for left panel. We'll be using a structural stack up, which will be having 6 number of layers over there. Apply and OK. Okay, not before. Okay. Okay, so I guess I made some kind of mistake over here. So create apply on the orientation of left side. So this particular material will be your structural stack up with 6 number of layers over there. Okay. After this, there will be a ply, which will be also using the same kind of material, the core material over here. Create a ply after that, left panel, structural stack up with 6 number of layers. Apply. and OK. Now we have created the left side of the model as well. After this, we'll go for the right side. So right panel, apply, and OK. So over here as well, we need to create the ply itself with respect to this right side oriented selection set. Now structural stack up with 6 number of layers over there, apply, OK. After that, one more ply that I need to create over here for the core, apply, and OK. Now after this, there will be another ply which will be for the structural stack up. So 6 number of layers for this one as well. Now once you have defined these all things, I need to create one more ply over here for the seat section, because seat was the left out over here. So seat, create ply, where we are going to select the oriented selection set for the seat, structural stack up with 6 number of layers over there. Okay. You should not miss any particular region from the geometry, because if you would mix up or either miss some of the particular regions, then you will create some different kind of composite composition itself over here. So that's why you need to be more precise with creating the composition of the layup as well. So once this is done, now the last one that is left out over here is the wrapping section that we are going to apply on the overall geometry through the selected element set. So create ply. This would be for the oriented selection set that we didn't named as wrapping over there. So this will be just the structural stack up over here. So there won't be any core which will be present. So just 2 number of layers we will be using over there. Apply and OK. Once this is done, now you can see we have done the overall like regions have been applied on the model over here. So if I would go to the layup plots over here and update this particular region, the thickness that we have generated on the model. So as you can see, the overall thickness on the model is being showcased over here. So the front has somewhat 20 mm of thickness over here. The rear and the seat might have more amount of thicknesses than just the particular monocoque model, where there might be more amount of loading, torsional loading stresses those might be getting generated, has 13.2 mm of thickness that has been generated over here. So you can even see the particular direction of your plies that you have created on the model. So you can apply this particular regions where the particular ply will be oriented and the directions of your ply. So over here you can see with respect to this particular region in which particular direction the plies will be created. So as you can see, due to the draping that we have applied on the model, the particular model is not getting changed, or the orientation or the fiber direction is getting much changed over here. So that's the advantage of using the draping condition over here. So if I would go to this draping mesh as well, so if I would click on update it and click on show, then I can select any of the ply from the model. So if wherever I have applied the draping, so that is the top section and the bottom section. So if I would select any ply over here, so you can find out over here what kind of composite or the layup that you need to create or the laminate that you need to create for the by the manufacturing process, so that it can be directly applied on the mold that you have with you. So you can see this is the actual structure that you need to create while manufacturing your particular composite layup on the model with respect to the draping surface. So this particular draping can be exported over here. So if you would click on the export flat prep over here, you can export it in terms of any step or IGS file as well. So that particular thing can be exported and you can create such kind of structure, and you can particularly like create a manufactured model with respect to such kind of shape over there, which can be directly applied on the model. After that, if we would just create some section cut over here, so I will just make use of the section cut where the normal will not be the X direction, sorry, Z direction. So it will be the X direction over here. So in this direction, it would be more easier for us to recognize what kind of plies that we have created. So if I would change the analysis ply over here, click on apply. So over here, as you can see, the fiber orientation and the ply, the ply thickness has been showcased to us with respect to the section cut. So I'll just close this one. I'll just hide some of the elements that I have created over here. So if I would just hide this uh, front or either the top section of the model, hide it, and go to the selection set. Okay, so instead of it, it is the better way through which we can see what kind of like thickness that we have provided to this particular ply and what kind of plies that we have created over here. So I'm not able to zoom much to the model over here. So if you would see, there are four number of layers over here which are representing your stack up. So two wovens at 0 and 45 degree, and once again that similar layer is duplicated over here. And then there is a single line which is representing your core thickness, and then again there are four number of layers of the woven material. So this kind of particular section you have applied over here on the overall geometry itself. So now once this is done, we are going to consider this particular model itself for the structural simulation. Now we'll just update the particular setup that we have done from the ACP pre. Okay, so once this is updated over here, I'll just select the static structural and drop it over here in the project schematic window. I'll drag this setup over here and drop it into the model. So it is asking me to transfer solid composite data or shell composite data because we don't have the solid. So we'll go with the shell composite data itself that we did created. So I'll just click on update upstream components over here and open the static structural so that we can perform the static structural simulations on the model and even post process the model over here itself. Okay, so as you can see now the overall mesh has been generated on the model with respect to the thickness of the composite that we did created. So you can see it has obtained the same kind of composite thickness that we did provided over here. So if I would go to the geometry, you can see the thickness that has been defined with respect to the composite, which is now not modifiable over here. So after that, if I would go to the imported plies, so you can see all the plies that we did created have been imported over here, and wherever those are located, you can see those regions over here on the model. So after this, we have the name selections as well, but we need to apply the boundary conditions and the loading conditions as we did discussed after orientation and ply modeling. We need to go for the structural simulation over here. So over here in the structural simulation, I'll just right click and insert a fixed support that I'll apply on the back end of the model. So these two surfaces I have selected to be applied as fixed support, and then later on I'll apply some kind of remote forces over here to apply the torsional boundary condition with respect to the conditions that I have. So I'll select these four surfaces from the model over here, apply where those suspensions were attached to it. Then the global coordinate system, we want to make use of this Cartesian coordinate system that I did created over here. So the Cartesian coordinate system with 0, so that all the number of faces will be focusing on this Cartesian coordinate system itself, which is your particular wheel section. So whatever the wheel is providing the particular torsional effect on this geometry will be from this particular region itself, where my Cartesian, like the coordinate system is available at now. So I'll change the particular load definition from vector to component. And now I can apply the load in the downward direction over here in the y-axis. So in y-axis, so as this is a torsional load, so if I'm applying a negative or a positive y-axis that is tending in the downward direction, so in the another side, I'll be applying the force in the upward direction over there. So that is with respect to your particular fixed support that you have provided in the back. So I'll mention this particular value to be 6780 newtons. So I just have a random value defined for this particular region over here. So this torsional boundary condition is provided with respect to the suspensions which are connected with respect to your monocoque as well as the wheels of the model. So this is the first remote force that I have applied. So the second I'll apply on the another end of the body over here. So another side of the model. So I'll just select these four surfaces once again, apply it over here. Instead of global coordinate system, I'll make use of the local coordinate system that I did created. So I'll just mention all the coordinates to be 0. So it will just focus on the coordinate system itself that I have created. Then changing vectors to component and defining the particular load in the positive y direction. The same kind of load itself in the positive y direction, so that torsional effect will be provided to the overall geometry with respect to the suspension regions. Once this is done, I'll just go to the solution over here, insert the total deformation, insert a stress with respect to the layers, not the plies. So you can even select whatever ply that you want to analyze for. So if I want to select any particular single ply on which I want to find out the stress on the model, I can do that thing as well. Or either I can select the entire section itself to be defined under the stress regions. I can import a composite tool as well where I can check the particular failure of my region. So over here, I have defined the property for my particular material over here. So the actual properties those were present were your particular orthotropic stress limit, strain limit, and also the SIVO constants are provided over here. So that means I can make use of this maximum strain, maximum stress, and the SIVO constants as well. So to define the ply criteria. So once that is done, I'll just click on solve over here. So in the post-processing part of your Ansys Mechanical, there are lot many things that you can post-process over here, which is somewhat similar to the Ansys ACP post as well. So whatever region you can, whatever things that you would like generate the post-processing for using the Ansys ACP module, the post-processing tool of the Ansys ACP, it is also possible using the Ansys Mechanical now. So once the solution is solved over here, once the results have been generated, you can click on the particular solution tab over here. So whatever worksheet that you might have. So if I would click on this solution and click on the worksheet over here, so you can see what kind of results that you can analyze from the model. So basically all these kind of regions, wherever you want to find out the results on your particular model, these are the things on which you can analyze the results. So basically you can create your own user defined quantities, user defined results, and you can define these particular regions over there and analyze whatever kind of particular data that you want to analyze with respect to the model. So you can just right click on the model and you can define your own user defined results over there, and you can use this particular expression which is defined over here to particularly obtain the output in terms of either stresses, strains, force, energy, temperature, and all other things. So these kind of results are available for your model, which can be particularly imported from here. Now, whatever the results that we have generated from the model, as you can see, it is generating 10 mm of deformation in the overall model over here. So if I would just go to the equivalent stress, you can see it is generating 215 megapascal of stress on the model. And the particular region where there is more amount of stress is this particular region over here due to the torsional deformation that we have provided to the geometry. So if I would go to the results to give a more better visualization about the higher stress regions, so you can see these particular regions are the higher stress regions which are being generated on the model. So you can click on the maximum tool. So it will generate your particular results with respect to it. And if you would go to the inverse failure, inverse reserve, reserve factor, so you can find out which particular region is being affected over here. And you can see due to what kind of forces or what kind of stresses this particular maximum value has been generated on the model. So these kind of simulations can be run through the Ansys ACP by particularly integrating it with the Ansys Mechanical. You can do perform the post-processing part as well. Once this is done, you can go back to your Ansys workbench screen where you have completed your particular results. Now, if you want to check out if there are particular variations in the model with respect to the variations in the number of layers that you have used over here. So basically for top section, if you have used two number of layers, if I would increase more number of layers, what would might have happened over here? If I would reduce the thickness of the honeycomb structure, so whatever material that I'm using, the honeycomb material. So if I would reduce the particular thickness of this honeycomb structure, what changes the model might get generated with? So those kind of things can also be analyzed with respect to the parametric study. So parametric study in Ansys ACP is very much easier in comparative with different kind of simulations. I can add this particular result of the equivalent stress to be a parameter over here, and it will be set as the parameter set over here. Now this is my output, but whatever the inputs are there, those can be defined with respect to this ACP module's parameter set over here. So if I would click on create parameter, firstly I need to define the object. So if I would select the core material of the fabric, so that can be defined to be my input parameter over here with respect to the category. Now what property I will be including to be the parameter over here, either the material itself, the price or area, or the thickness. So the thickness of the core I want to consider to be the parameter. So if I would click on apply and OK. Once this is done, I can include one more thing. Many more things you can include to be the parameters. But as of now, I'll just select this particular thing over here. So apply modeling, where I'll select the number of layers to be my input parameter. Apply and OK. Once these two have been set to be the parameters, so as you can see, the parameter set has been developed over here. So if I would double click on it, you can see my two input parameters are there, and with respect to which I have a single output parameter where I have the thickness to the core, and for the top ply that I have created over here, which has two number of thickness, two number of layers over there of the stack up that I did created. So if I would change this particular value, if I would increase the core thickness to 14 and reduce my particular value to 1 over here. So how it will get affected with respect to the results? If I would click on update design point, before that I'll just reduce this value to 7 over here, and the stack up layers from 2 to 6 I'll get generated over here. So I want to check what kind of variations will be done with respect to the maximum stress on the model. So this will close everything which is open in the background with respect to our model and start working on the simulation over here. So this will be our final step over here through which you can analyze the parameterization of your particular simulation of the composite model, and you can particularly optimize an optimal composite layup as well for your particular simulation model. So if anyone has any kind of doubt with respect to this simulation, then they can ask the questions in the chat box as well. So meanwhile, it will keep on solving. If anyone has any kind of doubts and all, they can type it in the chat box. So this might take a little bit of time. As you can see over here, it is updating the setup component in ACP pre firstly, and then it will go for the solution. So this might take a little bit of time to update the results over here. So meanwhile, if anyone wants to ask something, then please go ahead. So we'll just wait for the first design point to get solved, and then later on we'll just wind up with this session then. Okay, so it didn't change much with respect to the variation in the model over here. So as you can see, if we are increasing the core thickness a little bit more from 10 to 14, and if we are reducing the number of layers from 2 to 1, the particular stress in the model is remaining the same over here. So we'll just check whether if there is any modification with the second design point or not. So this way you can particularly make use of the parameterization as well. So this will help you to like save your computational time instead of going again and again with respect to the changes in the number of layers and the core thicknesses and all. So you can change your particular like whatever modifications that you want to make with the model that you can add as a parameter, and it can be solved over here. Yeah. Yeah, the recorded session will be shared with you. Yeah, that is not just a limitation over here. See, parameterization is always available for different kind of simulation. So whether you would perform a structural simulation or whether you perform any different kind of simulation, the parameterization can be applied to any one of them. Okay, so it didn't change much with respect to the stress values over here. I guess though this might be a little bit irregular result that I have got for the stress values that which is present over here. But you can just give a try with your particular model, and you can just check what kind of variations you might generate for the geometry that you have with you. So I'll also share the model with you, so you can just give it a try by practicing on your own, and you can check what kind of variation you might get with respect to the changes in these values over here.